I just like the sound of it.
Hey, what's up, guys? It's been a minute since I made a video, but I wanted to whip up a quick video going over 4.4, 4.5, talking about functions and inverses, okay? So let's go ahead and get started. Let's see here. So we've learned about inverse of functions, undo the functions, all right? For example, subtraction is the inverse of addition, logarithms are the inverse of exponential, and roots are the inverse of square functions. All right. The graph of an inverse is a reflection across the line y equals x. All right. The inverse may or may not be a function. Okay. The inverse may or may not be a function. All right. So remember the vertical line test. The vertical line is literally a vertical line. All right. It's just a vertical line. All right. That's the vertical line test. All right. It can determine if a relation is a function. So if you have some function and the vertical line touches one time, it touches the function one time. All right, like it does right here. Right? Any vertical line, I can draw another vertical line. It only touches this relation one time. That means it's a function. All right. Use the vertical line test to determine if this is a function. All right. Now, if I found the inverse of this, I would use the horizontal line test, which is just a horizontal line, to see if it touches more than once. All right, touches that relation more than once. If it touches the relation more than once, then it is not a function. All right. Vertical line test, if it touches a relation once, it's a function. If it touches more than once, it is not a function. Horizontal line test. All right. You look at the inverse. All right. If the horizontal line test touches the inverse relation more than once, it is not a function. If it only touches once, it's a function. All right. So let me just show you what I mean, because I just said a mouthful, man. I got tongue tied myself. So here you go. Right here. If a horizontal line passes through more than one point on a graph of a relation, the inverse relation is not a function. So look, listen, we'll do it. All right, let's just do a line test real quick. So I'll use this yellow. So right here, you see that yellow line I made right there? See how it touches that relation right there one time? Even if you made it down here, it only touches one time. All right, that line right there, that yellow line touches that relation once. All right, so this is a function. Now, if you draw the yellow line, the horizontal line right here, or right here, see how this line touches twice? It makes contact with that relation right there and right there. That means this inverse is not a function. All right, it touches right here twice. This inverse is not a function. But here it only touches once. That one yellow line only touches once. So this relation right here, that red line, that red relation is a function. So here, let's use the horizontal line test right here to determine if these are functions. If I draw a horizontal line right here, it touches once right there. So this is a function, even if I did it again. Right, it only touches one time. That's a function. All right, I'm going to write function. All right, right here, if we draw a horizontal line, see how this one line touches right here twice? All right, or heck, if I drew right here, that's a horizontal line. See how it touches 4 times? All right, this is not a function. Right here, if I draw a horizontal line, it touches only one time. All right, so this is a function. And then again, right here, it touches twice. Oops, sorry, right here. So this is not a function, okay? Now, remember that to find an equation for the inverse of a function, you can switch x and y and solve for y. Since x and y have been switched, the domain of the function will be the range of the inverse and vice versa. All right, so let's dig in. You have this right here, f of x. All right, if I wanted to find the inverse, the first thing I would do with this function is swap x and y. So see how right here, f of x and y, they're interchangeable. All right, the function equals this or y equals this. All right, if you were to put in your TI-83 or 84, you would say y equals. All right, it's the same thing. All right, but here you go. We have it written in y form. Y equals 1/2 x plus 2 squared. The first thing you do is swap x and y like this. So you have x equals 1/2 y plus 2 squared. All right, I'm just reiterating what you see right here. All right. So once you swap x and y, then you are going to solve for y. So right here you would see the square. You can't do anything to the parentheses. All right, they're isolated inside the parentheses. So we're gonna evaluate this for that square. All right, we want to remove the square. So we take the square root on both sides of the equation. All right, so this square and that square root negates each other. So now I have the square root of x on the left plus or minus the square root on the left equals 1/2 y plus 2. And then we just do the additive inverse property. Not for all, I mean the inverse property of addition. All right, which means I can subtract 2 on both sides. So when I subtract 2 on both sides, I end up with this right here. Plus or minus square root of x minus 2. All right.
I just like the sound of it.
Right here. And then do the inverse property of multiplication. So I'm going to multiply by 2 on both sides right here. Oops, wrong button. Multiply by 2 on both sides right here. Alright, and that clears this 1/2 out. So now y is by itself, and you have 2 times plus or minus the square root of x minus 2. Alright. And then you just find the domain and range. All right. Just find the domain and range right here. Because of the plus or minus symbol, there can be 2 values. There can be 2 y values for 1 x value. So the inverse is not a function. All right, and the notation cannot be used. All right. So again, what they're saying is this: if I plug in. And what they mean here is, if I plug in, well, this plus or minus tells me that there can be 2 y values. All right. Now, if I plug like 4 into this equation, I should only get 1 y value, not 2 different y values. All right. It's just solved to be the same thing every time, and that because of the plus or minus, it gives me 2 y values. So if you to test out that theory, just plug a number right here like 4. Right. You get 4. The square root of 4 is 2, so you have plus 2. Minus 2 is 0 times 2, which is 0. And then if you put negative 2 here, if you have 4 again, you get 2 with negative 2 minus 2. It's negative 4. And negative 4 times 2 is negative 8. And then that gives me 2 different answers for the same x value. And that's not possible, okay? All right, so let's move on to the next side. Right here, find the inverse of each function, determine if the function determine if it is a function and domain range. All right, right here, let's find the inverse first. So remember the first step. Well, we're gonna write this as y equals x cubed minus 2. Now we're gonna swap x and y. So x equals y cubed minus 2, and then we're gonna solve for y. So the first thing we do here is the inverse property of addition. So I'm going to add 2 to both sides. So x plus 2 equals y cubed. And then I'm going to take the cube root on both sides. And that'll cancel out or negate each other. So I have the cube root of x plus 2 equals y. All right. So now to find the domain and range, guys, well, all I do and really, again, man, here, let's do the domain. For the domain, all right, if I take this right here, x plus 2, this is a cube root. So because it's cubic, the domain, guys, is all real numbers, all right? Cubic functions, all right, this is a cube root. The domain and range are always all real numbers, guys, all right? All real numbers, or you can put negative infinity to positive infinity.
I just like the sound.
All right, they're the same thing. Sorry, my infinity looks so lopsided. All right. Over here, domain and range, man. Again, swap x and y. So x equals the cube root of y plus 1. Alright, so right here I'm going to cube both sides. So the cube and the cube root negates each other. So I have x cubed equals y plus 1. Then I'm going to subtract 1 on both sides. So I have x cubed minus 1 equals y. Alright, so there's the inverse. Alright, there's the inverse right there. And guys, oh, by the way, right here, forgot to mention it. That little negative 1 up here, that exponent, that means inverse right there. Y to the negative 1. Inverse, okay? So again, this is cubic, so the domain and range are all real numbers. Domain, all real, range, all real, okay? Alright, so, man, picking back up, man, right here, this example right here, it says if two functions are inverses of each other, they undo each other. All right. So the composition of two inverses will always result in x. Hey, that's the most important statement right here, man. It will always result in x. All right. Meaning, if I take the composition, all right, let's say I have a function f of x and a function g of x. All right. If I take them and make a composition, like let's say I put g inside of x, g inside of f, right? So f of g of x, and I simplify it, I should get x, all right? Or if I put f inside of g, all right, g of f of x, I should get x. If I get x, that means they are inverses. That's my target, to get x. If I get x, they are inverses. Now, if I do this and I get anything else other than x, let's say I got x plus 2 for 1, and I got x minus 17. They're not inverses. When I simplify them all the way down, if I don't get x, these are not inverses. All right, those two functions, whatever they are, not inverses. All right, so let's do this example so we can kind of elaborate on what I mean. All right, this example here. All right, first, here's the function f. Here's the function g. First, I'm going to do f of g of x, meaning I'm going to take this function right here, g, and place it or substitute it into f, the function f, right there where the x is. So see how we have 3f now. The function f is 3x minus 1. Well, instead of having x right here, I'm going to substitute g in place of it. So you have 1/3 x plus 1. All right, I plugged that right there where the x was, okay? If you missed it, just rewind it back a little bit and see what I did, okay? Now, right here, we're going to simplify it, all right, f of g of x. When I do that, this 3, I'm going to distribute the 3, all right, to the parentheses. So I have 3 times 1/3. Now, let me go over here real quick. Let me add a refresher. We're multiplying a whole number, all right, times a fraction. You multiply the whole number directly to the numerator. All right, if you remember, that's over 1. The whole number is over 1. So numerator with numerator, you multiply, and denominator with denominator, you multiply. Not cross multiply. Multiply straight across. All right, so 3 times 1 is 3. 1 times 3 is 3. 3 over 3 is 1. All right, or again, just multiply it straight to the numerator. So 3 times 1 is 3. 3 over 3 is 1, okay? So I just threw that in there just to talk about how to multiply whole numbers and fractions, okay? Because we're going to do a lot of that actually. So, all right, back here, 3 times 1/3. All right, we just did it. It was 1x. All right, and then 3 times 1 is 3. And then I still have this minus 1 right here. So now I have x plus 3 minus 1. All right, well, 3 minus 1 is 2, so I have x plus 2. Now I simplify this. And when I did it, I got x plus 2. I did not get x. So this means they're not inverses. All right, but you always got to check yourself. And the way to do that is to do the other composite function. We're going to put f inside of g, meaning we're going to go this way. We're going to substitute that right there where that x is, okay? You have to check yourself. All right, you can't just do this and then go, oh, I'm done. No, make sure your conclusion is correct. All right, so you said this is not inverse. Well, let's prove it. All right, we're going to do the composition the other way. All right, or the composite function. All right, the other way now. So, g is 1/3 x plus 1, right? So look, right there where the x is, I'm going to substitute in f. Like so, okay? So what you now get is 1/3 times 3x. That's going to be x. All right, remember what I said. Now, if you multiply a whole number, all right, you just multiply to the numerator. By the way, look, distribute the 1/3. So you have 1/3 times 3x, that's x. And 1/3 times -1, guys, is -1/3. And we still have the plus 1 right here, okay? Now, right here, I have -1/3 plus 1, all right? -1/3 plus 1. If you think about it, I have three out of 3 slices, I gave 1 away. So 3 out of 3 minus 1, all right, minus 1/3 is going to be 2/3. So x plus 2/3. Now, again, I want you to see that this is not x. So we just confirm they're not inverses. All right, they're not inverses, okay? Now, let's work through this example right here. This was from class yesterday. It's like 9:30 p.m. right now. I'm finishing it up. I haven't had anything to do, so I wanted to get this done for you guys. For this example, I'm gonna do this one. All right. This one is not. They're not inverses. All right, but this one, I'm gonna do this so you can see an example of what an inverse is. Okay. What a composition will look like if they are inverses. All right. So first, I'm gonna do f of g of x, meaning I'm going to put this g into f. All right. See how it's inside? So we have 2/3 times 3/2 x minus 9 plus 6. All right, plus 6. So now I have a fraction. I want to distribute that. So I have 2/3 times 3/2. That's 1x. Again, look, 2/3 times 3/2. Right? That's 6/6, which is 1x. Alright, so I have x, and then I have 2/3 times -9. Remember, multiply the whole number directly to the top, the numerator. So -9 times 2, -18, divided by 3 is -6. So 2/3 times -9 is -6, and then I still have the plus 6 right here. So -6 plus 6 is 0. I'm just left with x. So f of g of x equals x. Alright, because I have just x, that means they are inverses. There's a question on your test, man, just like this. Alright, it says prove or disprove, something like that. I can't think of the word off the top of my head right now. But you're going to basically use composition to show that the two functions provided are inverses or they are not inverses. All right, again, to check it, I'm not doing this one right now, guys. So I'm looking at this still. Now I'm going to do g of f of x. Okay, so I'm proving it. All right, like we did with the last problem above. I'm proving that my conclusion over here is right. Alright, so I'm going to this time put this function into this one. Okay, so I have 3 over 2 times 2/3 x plus 6 minus 9. So now right here we have 3/2 times 2/3, that's 1x. And then we have 3/2 times 6. Well, remember, multiply that straight to the whole number. So 6 times 3 is 18, and 18 divided by 2 is positive 9, minus 9. So 9 minus 9, that's 0, that cancels, so I'm left with just x. So g of f of x equals x. Again, they are inverses, so this is true. I got just x. But anyway, man, that's this video, man. It's under 10 minutes, so I hope this helped, man. Catch you later.